Hello friends, my name is Jalal and today we're diving into the exciting world of AI and LLMs. That stands for large language models. Buckle up, we're in for a fascinating ride. In this inaugural series of videos, we will be embarking on quite a journey together. We'll be harnessing the power of the OpenAI API to construct an AI assistant. Throughout the series, we'll unravel the mysteries of LLMs, first exploring how they function, evaluating user inputs throughout various methods like classification and moderation, processing inputs via chain of thought reasoning, chaining prompts, assessing outputs, and ultimately constructing an end-to-end customer service assistant system by orchestrating multiple calls to a large language model. So let's kick things off with a quick overview of LLMs. So what is an LLM? An LLM stands for Large Language Model, and in essence, a large language model sits on top of a foundation model. These models are pre-trained on vast amounts of unlabeled and self-supervised data, allowing them to learn from patterns in the data and produce generalizable and adaptable output. These models can be gargantuan in size, sometimes spanning tens of gigabytes, and are trained on colossal amount of text data, potentially reaching petabytes of scales. That's millions of gigabytes. And LLMs boast among the highest parameters count, with parameters dictating the model ability to adapt and learn. Okay, now let's talk about the mechanics of how LLM operates. At the heart of an LLM lies three core components: data, architecture, and training. The data component involves feeding the model enormous quantities of data, text, probably, to learn from. And for the architecture, LLM typically uses a neural network, with the transformer architecture being a popular choice. This architecture empowers the model to comprehend sequence of data, such as sentences or lines of code, by considering the context of each word in relation to every other word. During training, the model learns to predict the next word in a sentence. Initially, it's making random guesses, but throughout iterative adjustment to its internal parameters, the model refines its prediction until it can reliably generate coherent sentences. This iterative process of prediction and adjustment gradually enhances the model's proficiency, enabling it to understand nuances like the difference between bug, yellow, sky, or bottle. Furthermore, fine-tuning allows the model to specialize in specific tasks by training on a smaller, more targeted dataset, thereby refining its understanding and enhancing task-specific performance. But enough theory, let's dive into some code. Here, in this, we're going to talk about a large language model, the chat format, and the tokens. So here we installed OpenAI in TickToken. TickToken stands for, it's a library that counts the tokens inside for the input and the output. Here we're going to import our OpenAI, TickToken, and the OpenAI key. And then we're going to define our main function, asking the LLM to complete the prompt. It calls get completion. It uses the model GPT-3 Turbo. And the message is the role is the user and the content is the prompt we're gonna send. Okay, so here we're gonna ask it what is the capital of France, and hopefully it's gonna be yes, the capital of France is Paris. Cool. We have the answer. So let's get to another level. Defining system messages and user messages and assistant message in the same function calling. Here our function get completion from message, and we'll prompt the LLM and give multiple messages. Here's an example of what we're gonna do. First, we're gonna specify the role of the system. The role of the system, and the content is you are an assistant who responds in the style of Dr. Seuss. And then we're going to define the role of the user. The content is write me a very short poem about a happy carrot. And the response is in a garden so bright, blah, 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 blah. So it answered the question in a certain style. Cool. And now we're gonna use another type, like the length. Here, the role for the system is not you are an assistant who responds in the style of Dr. Seuss, but write me a story about a happier carrot, but all the responses must be 1 sentence long. So we have the same content, but the user is prompting the same question, but the system is behaving differently. As you see, it's not in 4 sentences, but only in one. And in this one, we are combining the two. So you are an assistant who responds in the style of Dr. Seuss, and all your responses must be sentence long. And as you've seen, it's a different sentence. It's a different result, because here the result is in the style of Dr. Seuss. Okay, and in this last example, we see how many tokens we are sending and receiving for the same prompt. So get completion and token count, and here we're gonna use the tick token library to count the tokens. So ploop, the message is you are assistant who responds in style of Dr. Seuss, and write me a message about a happy carrot, and he's gonna print the response, and the token is, we've used 35 tokens in input. Completion is 45, so the total is 79. Cool. So with that, we conclude our first short video of the series, and in the next videos we're gonna explore how to evaluate the user input via different methods, how to process inputs via chain of thoughts, how to chain prompts, and how to check and evaluate output. In the description below, I'm gonna link to the prompts and to the Colabs to let you explore and dive into the code by yourself. Thank you, everybody, and see you in the next video.